Protractor's gonna be hard to video, but we'll try it anyway. So before I jump into 3.4, I apologize. I don't know what happened yesterday with the 3.3 homework that was assigned. I think I know what happened, but I can't be sure. So I was in big ideas logged into the 6th period class when I assigned. Well, I didn't assign your homework to the 6th period. That's not what happened. But when I went to your guys' class to assign the homework, they must have never switched textbooks, which is odd to me. That's never happened before. I can't even delete the assignment because I never assigned it, or so they say. It's not showing up on my big ideas, and I didn't realize that until Claire asked me to unsubmit hers, and I went in there and it looked like I never even assigned it because I never did. I never assigned the 8th grade 3.3 to you guys. I somehow assigned the 7th grade one. Now I've assigned you 7th grade assignments before, but every time I've done that, I've also always had the 7th grade book linked to your guys's big ideas account. Well, it wasn't linked to your guys's big ideas account. So it was glitched. What you never, it's funny that you never thought to come up and say, hey, it seems like we are doing equations, but where's this whole 180 degrees in a triangle, 360 degrees in a quadrilateral, 540 degrees in a pentagon? Where's that coming into play? Because what you guys were working on was the 7th grade 3.3. And I don't know how they assigned it to you. Like I said, you're not linked to that textbook. So that was just a glitch in the system. And for those of you that started it, I apologize. I can't delete it because it doesn't exist. The assignment does not exist on my computer because it was a glitch. No, because I won't even know what your score was. Or you could screenshot it and copy it off somebody who did it. No, there will be no points awarded for that 3.3. But there is another 3.3 that clearly says that it's your course 3 textbook. And I think the title of it says Angles and Polygons. That was the title of the lesson yesterday. And that one you can do for full credit. So I apologize for that. I'm not sure what happened there, but it was just a big ideas. That was a big ideas glitch. Well, I sent out that thing on Google Classroom yesterday. Did you read that? Where it said, attention, please read, attention, attention. Yes. Stop working on 3.3, use the 3.3 that's now assigned. You should pay attention to Google Classroom more. Caleb.
So, oh yeah, if you like submit it and get like 0%, it'll go away.
Sure, it's already gone away for me. Like I have no way of accessing that assignment. I have no way of deleting it, changing the due date, changing any of the questions on it. I can't do anything because it says that I never even assigned it, which is true. I did not assign that assignment. So why it's there, I don't know. But your 3.3 and 3.4 are there now. No, it will not go into Skyward. So you do not need to finish it at all. It is a dead assignment. It's gone. We're paper. Destroy it. All right, on to 3.4. 3.4, using similar triangles, says use a protractor to measure the missing angle of each of these triangles. What can you say about them? We have one triangle that is very big and one triangle that is very small. And if I measure the missing angle, for those of you who don't know how to use a protractor, to use a protractor, you line a protractor up on the angle and then you rotate it to where it lines up on so this little divot right here. Protractors are always different, but you can see a little divot right there. That's where I put it on the vertex of the angle, and I rotate it to where it lines up with that line on the triangle. Well, that's not helping me. I got to do this one upside down. There we go. And we can see this is what, about 90 degrees, right?
Yep.
Okay. The cool thing about a protractor is there's no wrong way to hold it other than the whole way I was holding it, where I was trying to measure the space out here, which isn't helpful. Because they've got numbers 0 through 180 counting this way, and then 0 through 180 counting this way. So you can measure it like that, or you can measure it like that. And as long as you know this is acute, I should be using a small number, or this is obtuse, I should be using a big number, then you can use either a small or big number and not have to measure it in an awkward angle. So that's a 90-degree angle. Let's check this one. We'll Let's do it this time, just to prove that we could do it. Okay, let's hold it this way. Okay. That looks again like it's 90 degrees. So they're both 90-degree angles. So I'll just put a right angle thing there.
Yeah.
Well, they should be, shouldn't they?
Yeah.
Because that would have to add that up to 180. Let's check it again.
Doesn't look like 90.
Let's check it again. Maybe I just used the bad triangle. I'm getting this one. I'm getting a little bit more than 90, but it's still closer to 90 than it is 100. So yeah, it should be 100. It's obvious. So right now, what we have here is we have the problem of the textbook giving me a triangle that is not drawn to scale. That's exactly right. So let's go ahead and put 100 degrees in there because that's what it should be, and we know that because of the triangle sum theorem.
You're using a fault.
Unless the triangle.
No, this is a good protractor. I know that because it goes from 180 to 0 and vice versa. Yeah. If it went to 179, I'd have a faulty protractor. Now, it says when two angles in a triangle are congruent to two other angles in a triangle, the third angles will also have to be congruent because we know they'll have to add to 180. So what this is saying is if I know what two of the angles in my triangle are, I should know what the third angle is. Let's pretend I don't. I will be able to find it. I should be able to find it. Let's just say I only know two. And I see that these two angles correspond and match up with two angles in another triangle, whether they're the same size or not. Those two triangles have to be similar because the two missing angles, the top angle and the angle A in both triangles, will have to be the same. They'll have to be. As we mentioned, it'll have to add up to 180 in both of them. Okay, so I don't need to check to see if all three angles are congruent to see if it's or all three corresponding angles are congruent to see if they're similar. I just need to check for two. So therefore, the triangles will be similar. And we know similar means same shape, but a different size. Same shape, but different size. And remember, similar shapes, all the corresponding angles are congruent. All the corresponding sides are what? You're not listening to me. You're writing down and you're working ahead. What was that, Claire? Thank you. Someone was listening. The corresponding angles in similar triangles are congruent, but the corresponding sides are proportional. So we're going to be using some more proportions in tonight's homework, just like we did in the last chapter when we were talking about similar figures. Okay. But this is what I'm trying to say is if you know two angles match up in a triangle, if these two angles match up and correspond and they're congruent, and these two angles match up and correspond and congruent, then you know the third angle is going to match. It's going to have to match up. So they will be similar. So let's look at these two triangles. They're definitely not congruent, but it doesn't say if they're congruent. It wants to know if they're similar. Is there a 75-degree angle in the other triangle?
Yes.
Yes. Is there a 50-degree angle in the other triangle? Yes. Then without even knowing what X and Y are, I know they're the same. They have to be, because if you take 180 and subtract 125, and then take 180 and subtract 125, you'll get the same answer for both those angles. They will be similar, because if the corresponding angles are all congruent, you have similar shapes. Okay, so these are similar. And I verbally explained it, but let me write it out again so you can understand. Similar because if two pairs of corresponding angles are congruent, then they're similar. I guess I should have said similar because two pairs of corresponding angles are congruent. Two pairs. Okay, look at the next example. Is there a 63-degree angle in the other triangle?
Yes.
Yes. Is there a 54-degree angle in the other
No.
triangle? Are you sure?
There is.
There could be, let's check.
Yeah.
180 minus 63 and 63 makes 126. Who can do that math for me real quick? 54. There is a 54-degree angle in the other triangle. So this is 54 degrees. They tried to trick you. Just because you don't see it initially doesn't mean it's not there. You might have to use the triangle sum theorem to double check that there's not two sets of corresponding angles. So there's a 63. There's a 54. And then I guess we could, from this, say that, well, this got to be 63 degrees, then it has to be. All right. So this is going to be similar for those reasons. Because if two pairs of corresponding angles are congruent, then there has to be three pairs that are congruent. There will be three pairs. Okay, let's check these right triangles. Well, we know there's a right triangle in both, so there's one set of corresponding angles. Okay, let's double check our math here. I need someone to run the numbers. What's 180 minus 90 and 38 makes 128? 52. Is there a 52-degree angle in the other triangle? Nope, there was a 42 degrees. So this is 52. Okay.
42.
Well, I know that one. This one can't be 52.
No, but you
The
said
answer is
52 and
52.
38. Oh, because I thought it was 103.
Oh,
What?
sorry. Even if it looks like it's a right angle, it might be 100 degrees. We learned that from the first one, right? But not this one. Yeah. So we have one pair of corresponding angles. And when we did the math, the only way this would have worked is when we subtracted 180 and then this 90 and 38 degree angle, if we would have gotten 42. Because then if this was 42, that would have matched up and these would have matched up. But this can't work because again, that's not 42 degrees. If I run the numbers over here, I won't get 38 degrees. So these aren't similar.
TJ Buck, please come to the office. TJ Buck. And Hannah Hoover, please come to the office. Hannah Hoover, please come to the office.
All right, now let's get to the side lengths. This is the really important part of this section, in my opinion, the side lengths. It says use the fact that the two rays from this, oh, this is what we're doing tomorrow. Make sure you bring your jackets tomorrow or sweatshirts. Yeah. Be a little on the chilly side, but it should be the warmest part of the day. We'll go out at around 2 o'clock. So it says use the fact that two rays from the sun are
We should just wait.
Honestly.
well,
Let's do it.
let me see if there's a day where it's going to be warmer next week. Let me check. If there's a day it's going to be warmer, we'll just use success time next week.
It's supposed to be 60s all
Yeah, I
next
think
week.
it's plenty fine.
Okay, we
And I
might
think
make
we
it.
should
We might
still
make
do
it.
tomorrow.
We might make it next week then if it's going to be warmer. That way we can actually enjoy being out there. Because if it's 40, but then it's also windy, it can feel like it's 30. So yeah, we might just wait till next week. We'll do it. We'll do it. We just might do it on a different ST day. So anyways,
If you do the last bit.
Wait, so what are we doing tomorrow?
Spring break.
use the fact that the two rays of the sun are parallel, which is always true, to explain why triangle ABC and triangle DEF are similar. Then find the height of the flagpole. Okay, well, if this, what they're trying to prove is show you why this works before we do it. What they're trying to say is because I have a parallel line there and a parallel line there crossed by the ground, right? And the ground's the same height, so that we'll say that's a transversal. Okay. What we're going to have then is we're going to see that this angle here and this angle here are the same because they're corresponding. And we're going to see that this is a right angle and this is a right angle and they're the same because they're corresponding. So think about that. If I can prove that two pairs of corresponding angles are congruent, we just learned, well, all three pairs will be congruent then. So these are similar triangles. And what do we know about the side lengths on similar triangles? Man, I was really hoping you would have picked that up the first time. Caroline? They're proportional, exactly. So we can set up a proportion to find the missing height of that flagpole, much like you guys are going to set up a proportion to find the missing height of our light pole. Yeah, tomorrow's going to be soggy and cold. We'll just do it next week. Yeah, we'll do it next week. So your proportion would go as follows. The person's height is 5 feet. The flagpole's height is X feet.
Elena Smith, Whitney Parvin. and
The person's shadow
Cox, please come to
is
the
3
office.
feet. The flagpole's shadow is 36 feet. So that's not the only way you could set the proportion, but it just makes sense, right? We have 5 feet to X feet, height of the person, height of the flagpole, and then shadow of the person, shadow of the flagpole. But you could also do 5 is to 3 is X is to 36, and there's different ways you could set this up. Let's go ahead and cross multiply. You have a question, Cooper?
No, I have the answer.
Oh, okay. So what'd you get for 3 times X?
I got 3x,
And what'd you get for 5 times 36?
180,
And you divided by 3 and got what?
60.
60 what?
60.
60 feet. Yeah. Do what? No, you could do 3 over 5 and then 36 over X, not 16, but 36 over X you could do. So this is called indirect measurement. And indirect measurement uses similar figures to find missing measures when it's difficult to find them directly. Direct measurement would be taking a tape measure and measuring it yourself directly. We just can't do that on objects that are, well, like a flagpole or like a light pole or super tall without climbing to the top, and just isn't going to be realistic for this. Okay, I don't even have a tape measure that goes that far, so it wouldn't be accurate. This is actually more accurate than what it would be if we tried to guesstimate it. Okay, so this is what we'll do when we go out and do our shadow lab, when we have nice weather and it's a little bit warmer, and hopefully next, yeah, the sun's out. Yeah, sun's got to be out. We can walk out there in the shade and be like, well, this isn't going to work too well. So we won't do it tomorrow then. That's fine. That you may like that better. Maybe we'll watch some NCAA basketball since the game starts tomorrow. What if we watch The Parent Trap today?
Oh, nice.
Even better.
I say we do it.
I'd say take our extra, no kidding.
It's a great idea.
Why don't we finish this last problem, look at a homework question together, and then we can use the restroom.
Yeah.
All right. So you plan to cross a river and you want to know how far it is to the other side. You take measurements on your side of the river and make the drawing shown. Explain why triangle ABC and triangle DEC are similar. And then what is the distance X across the river? So let's first explain why they're similar. If I'm going to prove they're similar, I just need to find 2 pairs of congruent angles. I see one. The right angle, yeah. The 2 right angles are going to correspond. So there's one pair. Do you see
Yes.
any other angles that would have, yeah, which one?
X and 60.
Those are side planes.
Oh, okay.
Harrison,
2 angles touching our vertical.
that is exactly right. Nice job. The 2 angles that are touching here, so angle C on this side, or actually it's angle BCA, and then angle DCE, are vertical angles, and we know vertical angles are congruent, so they're going to correspond, whatever they are. I don't know how much they measure, but they're going to correspond and be congruent. So if we've proven that 2 of them are corresponding and congruent, then all 3 of them will be. So we definitely have similar triangles. And remember that this form of indirect measurement only works when you have similar triangles. So if we were to go out and measure our shadows at 11 a.m., that's all right, come back inside. We got it. We'll go back outside and we'll do the pole's shadow at 2 p.m. Well, the sun has shifted in the sky, resulting in different sized shadows. No longer will we have similar figures anymore, so it won't work. So we have to measure the shadows of ourself and the sun. Well, not the sun, ourself and the pole at the same time. Otherwise, it won't work because the shadows will have moved. Now, the sun and the earth are, well, the earth's constantly moving. So our shadows will move a little bit, but not enough to make a change. But if you go out 3 hours later, there will be a big change.
You could use chalk and like.
Riley.
Chalk.
So if we want to say that the sun's peak point was at 12, and before that it's going up and after 12 it's going down. So it'd be like 2 would be a little bit in the opposite direction for the paint.
Theoretically, the shadows would go like this, long, short, 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 then when it's right above you, hardly a shadow at all, and then they go like this. So you'd think there's a time in the morning and a time in the afternoon where the shadows would be the same length. I just don't know what those times are gonna be. And it's gonna be different each day too. But yeah, that's a good point. Okay, so now that we've proven the triangles are similar, we know that the sides are proportional. So I need to probably leave these here, to be honest. I need to figure out which sides correspond with each other so I can write the right proportion. So what I'm gonna do to make sure I don't mess this up, because it'd be very easy to, I'm going to use 50 first, which is between the right angle and the vertical angle. On the other triangle, what side length is between the right angle and the vertical angle? 40. Okay, so I want to make sure I have it set up right. So 50 feet over 40 feet equals, and then we'll call this, I don't know what this angle is, but we'll just say it's got 2 marks on it, right? So the right angle to the angle A is 60 feet, and then the other one's X. So we're just gonna cross, would you let her in, George, please?
Oh, he's waved at her. He was like, you're staying out
I'm
there.
just scared at her.
It's nice you could actually get up and answer the door for me.
How are you doing, Miss Lazar?
Hey.
George is like, I'm not letting her in.
Yeah, that's right, George. Don't let me in.
Okay.
Cooper, what happened to the middle? These guys opening the door?
Oh, I didn't
Stranger
hear you.
danger or what?
Resume recording here. There we go. All right, so we cross multiply. Who knows what 40 times 60 is?
2,400.
Okay, and that's going to work out nicely because 50 is going to go in to 2,400. How many times?
48.
So the distance across the river is 48 feet. There you go. We solved for X by using a proportion indirect measurement, right? We didn't actually measure. No one measured across the river. We used similar triangles to do that. Okay, let's look at a homework problem from tonight's homework. Number 14. It says the side lengths of a triangle are increased by 50% to make a similar triangle. Does the area increase by 50% as well? Explain. Okay. Well, if you're increasing by 50%, do you think that's going to increase the area by 50%?
Yes.
Because we've talked about ratios of side lengths to perimeter and side lengths to area. Was the side length ratio equal to the area ratio? No. The side length ratio was equal to the perimeter ratio, but the side length ratio was not equal to the area ratio unless you did what with the side length ratio? You squared it. So let's look at their work here. It says the area of the similar triangle, I'm going to say is will not or does not increase by 50%. The length of each side of the triangle increases by blank percent. So each side is multiplied by a scale factor of 3/2. Okay, so let's see if the triangle is increased by 50%. The length of each hold on, I spent a while since I've looked at this one. The length of each side of the triangle increased by blank percent. So each side is multiplied by a scale factor of 3/2. Okay. So it shouldn't be 50%. It should be, let's see, 50% is 0.5. What's 0.5 squared? 0.25. Okay. Hold on. If it's increased by 50% though, whoops, if it's increased by 50%, that means it's going to be 150% bigger. Because if you say it's 50% bigger, that means it actually shrunk, right? Okay. So if we square, that's where the 3/2 is coming from, right? Okay, that makes more sense. That's where the 3/2 is coming from. Okay, so 1.5, 150% is 3/2. And so what they're saying is that we need to square that to get what?
2.25.
9/4 or 2.25, which is what 1.5 squared is. So if you wanted to go the decimal route, that's fine as well. Okay, and so that's 2.25. And what's 2.25 as a percent?
2 1/4.
225%.
Oh, percent, I bet.
Okay.
25%.
Now, if it increases by 225%, remember, if you don't increase it at all, it stays at 100% of the size. So if 100% means it's not changing at all, then it's actually only increasing by 125%. Because if I said, hey, my triangle's 100% the size, well, it didn't change then. Okay. Because what's 100% as a decimal? One. What happens when it comes by one? Nothing happens. It's the same. It stays the same. Yeah. So it's going to increase. Now I'm confused what this blank is, and I'm trying to figure out.
It's 50%.
Okay, that makes sense because you're subtracting the 150 from 50. Well, is that what it is? Without pulling the homework open, I don't know what actual
Yeah, if you
options
pull the
are there.
homework open,
It will give you a 50% there.
100. Oh, wait, 50, 125.
Okay. So here's the actual work you need to show, other than writing your answers. And of course, you'd need to show that the area ratio is the square of the side length ratio, which we learned in our last chapter, at the end of our last chapter. And then you'd have to show that 9/4, which is that area ratio, is actually equal to 2.25, which is then equal to 225%. Maybe I should put a percent sign. It's already there, but I'm going to put it anyways. Okay. All right. So there's a homework. A lot of people ask, well, here's the thing. I either get a lot of questions about this one or I get none. Because they're like, oh, I can just fill in the blanks and guess it. Right. So I figured we'd just talk about it. All right, so let's go take our restroom break. We'll come back and work on some homework.
And watch the parent trap. Oh, Steven. Dude, this homework is gonna be so.